Hey guys, Rod here. As promised, I said I'd take a look at the previous assignment and see if I could give you a couple of the answers. Now, I haven't got any answers back yet, so I can't guarantee that my answers are going to be correct, but this is how I would have tackled them. So we'll take a look at it. You will see on the right-hand side of the screen, I have my handwriting program, and on the left-hand side of the screen, I have the instruction set. So we can look at that. This will be the instruction set that we will get when we are into the exam. So, the first question is, write an instruction sequence to swap the contents of register 0 and register 1. A third register, such as register 2 or other, can be used to facilitate the swap operation. So if you remember when I said before in the previous video, the microprocessor only remembers one command at a time. Now there is no swap command to swap one register with another register. If you look down through the instruction set, we don't have one for swapping registers. We can copy a register, we can store, and we can load, but there's nothing here for swapping them. So what we'll have to do is we'll have to copy it. So you can see right here, this MOV command, RDRR, it's the copy register function. It copies the RR, the second one, into the first. So, to answer this question, you have three instructions you're going to need. First one is the move. And we're going to move register 0 into register 2. So remember I said RD is the destination. That's the one we want to have next. So we're going to have R2, R0. So that means to move register 0 into register 2. Now we want to move into register 0, register 1. So now we've got the first half of the swap done. We've moved register 1 into register 0. Now to complete the operation, we want to move into register 1 what's in register 2. And that's all you need. That's the first question done. Question 2. Write an instruction sequence to store the numbers 1, 3, and 5 at data memory locations at 0x2000, 0x2005, and 0x2000A respectively. Respectively just means that number 1 goes into 2000, 3 goes into 2005, and 5 goes into 2000A. Now, in hexadecimal, each 2 digits represents an 8-bit number. So we have a 16-bit number here. That means we're going to need to use a 16-bit address, and that would be this Z register right here. So to load something into a register, we want this load immediate. Now there's two ways we can go about this. We can use a assembler directive to disassemble the number for us, or we can just do it by eye. We're going to do it by eye in this case, just to keep it fairly simple. So the low byte goes into register 30. So the low byte is this one right here, and this is the high byte. So in order to write that, we want to LDI. So we're going to load immediate. Now we want the register. So the register for the low byte is register 30. So load into register 30. And we'll load in the hexadecimal number 00. And then we'll load the high byte, LDI, into register 31, 0x20. So right now we have just in the Z register, we have this address. Now we want to put that number into it. We want to put this number 1 into the address pointed to by what's sitting in the Z register right now. And that's a different instruction because the load, you need to have a 16-bit. So right here, we could load into a register, something that's pointed to by Z. That's not going to help us. If we go down further, though, we can store direct. We can store directly into the memory location pointed to. You see here, this is in brackets. This means pointed to. And we're going to store what's in the register. In order to do that, we need to put that data into a register. So let's load an immediate value into register 0, and let's put the number 1 in there. Okay, so now we have our number 1 and the place we want it to go. So now this store address instruction right here, store indirect, will do exactly what we want to do. So if we do a store and then the Z and then register 0, that will store the number 1 in memory address 2000. So now we need to move to the next one. Now the 2000 doesn't need to change, so we just need to worry about the bottom part. So we can do a load immediate into register 30, and we want the bottom part, 0x05, and we need to update our data, so an LDI in register 0, the 3. Now we do our store into Z, register 0. Now the last one, we need this low byte, so load immediate into register 30, 0x0A, and LDI register 0, 5, and then we do our store, Z, register 0. And that's the second question. Question 3. Write a sequence of instructions to add the 3 numbers stored in 2000, 2001, and 2002, and store that sum at the data memory location at 2010. So, if we look down through our assembly code here, and we're looking for an add instruction. Get all the way back here, and here it is, add without carry. So, that's going to help us for the first one, because there will be no carry from the first addition, because this is the first addition. Now, a carry is when you add 2 numbers. If I add, say, 9 and 2, if I add 9 and 2, that gives me a 1 and a carry of 1. See how that's in the next spot? That's what a carry is. So when we add without a carry, we're saying the first 2 numbers that we're adding, we don't have to worry about a carry from a previous addition. So remember, the processor doesn't remember anything from the previous things. We have to do that work for us. So by saying add without a carry, we're saying this is the first addition that we're doing. We don't care about anything that you've done before. So we've got 3 numbers now stored in memory, and they're stored at a 16-bit address. So we're going to be using our old friend, the Z register again. So the first thing we need to do is to load into the Z register the first address. So we're going to load the low byte into 30, like we did before. So into 30, the 0x00, and into the high byte, register 31, the 0x20. So that's our first address. Now we want to look at this again here. The add instruction says add the first register and the second register together and put the total into the first register. That's the first one. You're also going to notice here all these flags. Alright, so here's the S register. And this is where the flags are. I, T, H, S, F, V, N, Z, C. So if you look here, it says Z, C, N, V, S, and H. Those are the flags that could be set by that. Okay? So we don't need to worry about the global interrupt. This Z flag right here. So if we look in our list of them, the Z flag is a 0 flag. So if you add 2 numbers, 0 and 0, it could set a 0. Okay? It indicates a 0 result in an arithmetic or logic operation. Okay? Bit 0 is the carry flag. Carry flag indicates the carry is in an arithmetic or logic operation. That's the C. Let me go back here and we look at the end, the negative. So if we ended up with a negative number, add 2 negatives, we still got a negative. Add a positive and negative, we might end up with a negative. 2's complement overflow. Okay, so when you do 2's complement, you can end up with 1 extra thing over. The sign bit works together with the N and the V, the negative and the V together. the half carry flag we're not going to worry about. The bit copy and the global interrupt, we're not really going to worry about those right now. The main ones to worry about would be the carry, because that's what we're talking about now. So we're going to use the carry. So first thing we need to do right now is we need to move this number into register 0. So if you remember, we had the load. We want to load from the Z register. Load indirect into a register from Z. That's what we're looking at. That'll work for us. So we're going to do a load into register 0, Z. Now, the next place we're going is 2001. So we could do another load instruction to load the 0, 1 in here, but 0, 1 comes in right after 0, 0. If you look here, there's a post increment. If I had a plus sign right here, this will automatically increment into this low bit by 1. So now, as soon as I do that, now the Z register is 2001. That makes it a lot faster for us. So if I do another load into register 1 of Z plus, this will grab 2001, the data there, and put it in register 1, and it increments the Z address to 2002, so it's all ready for us. But before we do that, we should do our addition. So if we go back and review our add is RD and RR. We want it to go into register 0. So if we do an add, register 0, register 1, that will add the contents of register 0 and register 1 and put the answer in register 0. So now if I do a load into register 1 from Z, don't need to increment it because we're not going anywhere else with that, that will now load a third number into register 1 because we don't care about it now. And then if we add register 0, register 1, now register 0 is going to have the total of all those three numbers added together. Now remember I said we needed to worry about the carry? This is our first add, so in order to catch if there was a carry, we need to add with the carry into this third addition. So now we've taken care of that. Okay? Now we need to put that information back into 2010. Now right now, we're pointed at 2002. So we need to change this low bit. So we do a load immediate, register 30, 0x10. And now, if you remember correctly, it's a store instruction. So we look here, store indirect into what's pointed to by the Z register from a register. So we do an ST Z, register 0. And that's the sequence of instructions to add three numbers and take the answer and put it back at 2010. Question 4. Write a sequence of instructions to copy the 3 bytes from program memory locations 2000 to 2002 to data memory locations 2000 to 2002, respectively. So, the first thing to notice is that these are 16-bit numbers, so we'll be using the Z register again. Second thing to notice is that these are both the same address, so that's going to be helpful. We only need to worry about storing one 16-bit number. The third thing to notice is this is from program memory to data memory. So that means we're going to need two different kinds of instructions. So if we look here, you'll see that this is load program memory and store program memory, as opposed to this store, which is data memory, and this load, which is in data memory. So the first thing we need to do, again, is to go back to our registers, and we're going to be using the Z register. So we're going to load immediate register 30 0 0x00 and load immediate register 31 0x20. Now we want to load from program memory. That's this LPM. Now we can do it quickly with this LPM command. It's just copying from whatever is pointed to by Z into register 0. That'll just save us from doing any extra stuff, so we just write LPM. So that'll load from program memory into register 0. Now we want to store that back into data. So we want the store command. So here's a store into Z, this register. Now remember, we want to do 2000, 2001, 2002. We've already gotten our data from 2000. So once we're done storing it, we want to go to 2001. So if we use this post increment, that'll save us some time as well. So if we do a store Z plus register 0, that'll take the data we copied from program memory and put in register 0 and put it into the data memory location. And then it'll move the Z address up to 2001. So now we're ready to do it again. We can do an LPM. And because that's 2001, we can store into 2001. So we can do a store Z plus register 0. Now now we're at 2002, so we can do again load program memory. And then we can do a store, but we don't need to increment it. We can just do Z register 0. Now if you look here in this last column, this is the number of clocks it takes for the CPU to do the different operations. And you'll see here, the store and the store plus don't take any different amounts, which is fine. That helps us out quite a bit, unless there's some notes here. And these may become important depending on the CPU, the microcontroller you're using. Not every microcontroller is going to be able to do things at the same speed or the same ability. So those are going to become important. You'll also notice no flags are touched. So we only need to worry about the flags for certain operations. Question 5. Write an instruction sequence to subtract the values stored at data memory location 2000 from the sum of the values stored at data memory locations 2010 and 2011, and then leave the difference in register 0. So we should take a look at the subtraction one first. Okay, so we have a subtraction without carry or subtract with carry, and it says it subtracts the second register from the first one and then puts the answer back into the first one. And since we want to subtract this value from this value, then we should probably put the answer that we wanted, this sum, in register 0, and that's where it's going to leave the difference. That works out because the add without carry also leaves its answer in register 0. So the first thing again, because we're dealing with this 16-bit number, again, we need to load our Z. Same thing as always. So LDI, register 30. So we're going to start here at this 2010, because that's where we need, that's the one that has the addition. So we'll use the 10, and then load immediate, register 31, 0x20. Now we can load that into our memory. So just to review again, we can load directly from Z into a register, or we can do this increment. Now if we use this increment, that'll point us at 2011, so we'll use that. So we're going to load into register 0, Z plus. So there's our first number. And then we're going to load into register 1 from Z. We don't need to do the plus because we don't care what's the next spot. So there's our first two numbers, and we can do an add. Add, and register 0, register 1. Remember the first number here is the RD, and that's where the answer is going to go. So now the answer to that sum is in register 0, where we want it. So now we want to move our Z address back to 2000. So we're going to change register 30, which right now is 01, or 011. We want it to go to 00. And then we're going to load into register 1 from the Z. So now we've got the sum is in register 0, and our new number is in register 1, which is just what we want. And we don't need to worry about the carry, because in this case, this is not a carry, but a borrow. So when you do subtraction, sometimes you have to borrow from the previous column. That's a borrow. We didn't do a subtraction, so we're not going to worry about it. We're just going to do a straight subtraction. Sub R0, R1. That will subtract R1 from R0 and put the answer back in R0. And that's the answer. I hope you guys found that helpful. I'll try to do assignment 2 next time. Thanks.